All right. Hello, YouTube. Coming to you live from the algebra room because I'm no longer teaching geometry. Ha 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 ha. Such a funny joke. Anyways, today's lesson is on theoretical probability. How are y'all doing today? I'm doing all right. Hope you guys are doing well. But anyways, theoretical probability. So, what is theoretical probability? Well, let's talk about probability first. What is probability? Probability is a measure of the chance that a specific event will occur. When all outcomes are equally likely, the theoretical probability of event E is the ratio of the number of favorable outcomes to the total number of outcomes. Here we have probability of event. That is read as probability of event is equal to the number of favorable outcomes over the total number of outcomes. Probabilities have a value between 0 and 1 and can be expressed as a fraction, decimal, or percent. The reason why probabilities have a value between 0 and 1 is because 0% is represented as 0 and 100% is the same thing as 1.00. In probability, we don't go above 1. So let's do some examples. The spinner below is spun once. Find each probability as a fraction, a decimal, and a percent. Don't do that. Just do a fraction. So probability of an event occurring where it lands on a multiple of 3. Well, let's check for the multiples of 3. It's going to be 3, 6, 9, 12, and 15. Is that correct? Yes. So probability of multiple of 3 is equal to the number of favorable outcomes, which is 1, 2, 3, 4, 5, over the total number of outcomes, which in this case is 16. So that is the probability. The probability of a prime number, we have to count again. Probability of a prime number is, let's check how many prime numbers there are. I don't think 1 is counted as a prime number. I believe 2, 3, 5, 7, 11, 13 are our prime numbers. Therefore, we have the probability of a prime number is the number of favorable events, which is when the spinner hits 2, 3, 4, 5, 7, 5, or 6. So there are 6 favorable events over a total of 16 outcomes, which will give us simplified 3 over 13. I believe you guys can do that. Now, probability of even or greater than 5. This one's a little bit interesting because now there are 2 conditions. Even or greater than 5. Well, even numbers are 2, 4, 6, 8, 10, 12, 14, 16. And we're looking at, don't do that. And we're looking at that's even numbers. And the probability of something greater than 5. So anything beyond this. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers greater than 5. 11 over here, 11. And then this is 12 and this is 13. Therefore, there is a total of 13 events over 16. When you say or, you have to count both instances. Now, odd and at most 6. So they're saying find all the odd numbers, which is 1, 3, 5, 7, 9, 11, 13, 15. And it has to be at most 9. So they cannot go greater than 9. So the only possible events are from 1 to 7. Now this time, this is exclusive. We do not count 15, 13, 11, and 9 because it is not 9 and at most, it's not odd and at most 9. Therefore, the number of events occurring is 4 out of a total of 16, which will give us 1/4, and that is our answer. Now for this one, you have to use a little bit of common sense maybe. Let's look at question number 3. What is the probability of drawing an ace or a diamond from a standard deck of playing cards? Well, first of all, there are 4 aces in a deck of playing cards. Out of those 4 aces, one of them is a diamond. So there's an overlap. One of them is a diamond. There's 13 diamond cards. And there's one that's an overlap. So what you do is you add 4 plus 13, which will give you, what is that? 17? I can't do math right now. And you subtract the number of overlaps, which is 1. So 17 minus 1 will give you 16. The total number of cards in a deck is 52. So the probability that you get an ace or a diamond is 16 over 52, which will give you 8 over 26, 4 over 13. 4 over 13, and we are done. We should be good. Ooh, okay. I need to go over this one as well. I should probably go through all the examples. Yeah, we'll just go through all the examples. Number 2, a pencil box contains 5 red, 12 blue, 10 green, and 3 yellow markers. If a marker is chosen at random, what is the probability that it is not yellow? Well, let's find how many of them are not yellow. There's 5 red, 12 blue, 10 green. Total of 15, 27 out of 30. Therefore, the probability of not yellow is equal to 27 out of 30, and we are done. Number 4. Finn guessed on the last 3 true or false questions on his math quiz. What is the probability he got exactly 2 questions correct? Well, this is where we use yesterday's lesson. Talking about this, was it sample size? Probability size? I forgot what it was. I forgot what you guys learned yesterday. Well, we learned that there are 3 questions. Question 1, question 2, question 3. And each of them have 2 possibilities, true or false, true or false, true or false. So how many combinations of answers can you get here? Well, it's 2 times 2 times 2. There's 2 choices per event occurring. So you have 4, 8 total outcomes. Now, which of those are exactly he got 2 correct? You might have to do a table or a tree. This might come in useful. First event, you either have true or false. Then from those, you have true or false. From this one, you get true or false. One more time, true or false, true or false, true or false, true or false. How many of them has exactly 2 trues? It's not this one, it's not this one, it's not this one, it's this one, not this one, and this one, not this one. So you have 1, 2, 3, 3. So you have a total of 3 out of 8. So the probability of 2 out of 3 is equal to 3/8. Boom. 2 standard dice are rolled. What is the probability that the sum of the 2 dots on the dice is at most 5? So it cannot be greater than 5. Well, this is a great example where we can use a table. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 6 choices here, 6 choices here. There's a total of 36 entries. Now, which one is at most 5? Well, let's check. Can it have anything with a 5? No, so this row is gone. 4 and 4, 4 and 3, 4 and 2. Nope. 4 and anything, actually, is no. So 6s, 4, 5s, no. We're left with these. Can we have 3 and 3? Nope, that's 6. So we cannot have that one. How about 3 and 2? 5? Nope. 3 and 2? Nope. 3 and 1? Yes, 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 yes. Therefore, there's 1, 2, 3, 4, 5, 6. 6 out of 36 probable events. Therefore, it is, give me 1 second. So we can say that the probability of x less than 5 is equal to 6, which is the favorable outcomes, over 36, which is total, which is equal to 1/6, and we are done. Boom. Phew. We can do this one together, I guess. No, this one's on your... No, we can do this one together. Students in the homeroom were asked if they have a part-time job and if they have their driver's license. The results are shown in this Venn diagram, blah, blah, blah. Probability of part-time job is 8 out of, let's find the total, 4 plus 8 plus 6 plus 7, which will give you 12, 18, 25. Probability of a part-time job is 8 and 16, so it's 14 out of 25. Probability of no driver's license is everything but the inside circle. So check, it's actually all of this, like this. So 4 plus 8 is 12, so the probability is 12 over 25. You should be able to get this. Anyway, I'm going to go on. Now, complements of an event. The complement of an event is a probability of the event not occurring. Since the sum of all probabilities in the sample space is 1, the probability of an event not occurring is 1 minus the probability of the event occurring. This, you guys see the little squiggly sign in front of the E? So it's probability of squiggly sign E. That means not. So probability that it will rain tomorrow is 11 out of 15. What is the probability that it will not rain? Well, the probability that it will rain, probability of the event happening is 11 over 15. So the probability of the event not occurring is 1 minus the probability of the event occurring, which is equal to 4 out of 15, and we are done. Easy peasy lemon squeezy. Now, experimental probability. Experimental probability is based on the results of repeated trials of an experiment. So this is IRL. For example, the spinner to the right is spun about 50 times. The results of each spin are shown in the table below. This is real probability. This is what happened in real life. Find the theoretical and experimental probability if the spinner is spun again. What is the theoretical probability that it will hit orange? Well, it's 1 out of 5. Red or green, 2 out of 5. Not purple, 4 out of 5. The experimental probability that it will happen is, let's see, orange. There's 12, so it should be 12 out of 50. What is the probability that it might be red or green using this? Well, red happened 5, green happened 10. So it's 15 out of 50. Since 50 is the number of times it was spun before, and not purple, so it's 43 divided by 50. All right. I'll see you guys later. Have a good time. Hit the like and subscribe button. Mr. Y appreciates it. See you guys later.